Okay, Module 4, Lesson 15, Sampling Variability in the Sample Proportion. Students understand the term sampling variability in the context of estimating population proportions. Students understand that the standard deviation of sampling distributions of sample proportion alters insight to the accuracy of the sample proportion as an estimate of the population proportion. Remember that a sample proportion or a sampling of a proportion should represent the population. So we can use sample proportions to determine or estimate the population proportion. Okay, we can use it to estimate. We can't get it exact, but we can use it as an estimation. So let's go ahead and get started here. It says a high school principal claims that 50% of the school students walk to school in the morning. A student attempts to verify the principal's claim by taking a random sample of 40 students and asking them if they walk to school in the morning. 16 of the sample students say they usually walk to school in the morning, giving a sample proportion of 16 out of 40, which is equal to about 40%, or it's actually exactly 40%. Which seems to dispel the principal's claim, right? He said it was 50%, but this only came out to be 40%. But could the principal be correct that the proportion of all students who walk to school is 50%? Well, let's make a conjecture. Our conjecture would be that a sample proportion, can be used to estimate the population proportion. Okay, so yes, he could be correct. Principal could still be correct, right? Because a sample proportion is only a good way to estimate the actual population proportion. So we would say that maybe you could have 40 to 60%, oh, not 6, in your sample proportions, okay? That would leave you to believe that, yeah, it could be around 50%, because you're getting some that are 40, some that are 60. So it's going to be somewhere in between there, right? So let's see. B says, develop a plan for how to respond. Well, help the student make a decision on the principal's claim by investigating what type of sample proportions you would expect to see if the principal's claim of 50% is true. You will do this by technology to simulate a flipping of a coin 40 times. So what we're going to have to do is when we flip a coin 40 times, we're going to see how many is heads. And we'll say that is the students that go to school or walk to school. Tails would represent students that are bused or by car. Okay, so let's go to page 2. It says, exercise 1 through 9, students should assume that the principal is correct that 50% of the population of students walk to school. Designate heads, okay, that's what we said too, designate heads to represent the students who walk to school. Simulate 40 flips of a fair coin. Record your observation in the space below. Okay, so let's go over here to this is a website, okay, and this is going to do a flip of a coin. So let's see here, probability of heads is 50%, number of tosses, we need to change that to 40. Alright, and let's do it. Alright, so here I did this just to show you that they're flipping the coins. So the first 2 there would be heads, the next 3 would be tails, and then we're given our total of heads and tails here. It already knew that there was going to be 18 heads and 22 tails, so there they are. So let's come back over here now. So if we come over here, of the 40 flips, we're going to record our observation. Well, we had 18 yeses, because remember, heads represents yeses, and 22 no's. So what is the number 2 says, what is the proportion of that? Well, 18 out of 40 is 45%. Which seems about right. We have 40 on the, we talked about having 40 as the minimum and 60 as the highest, right? So let's see now. It says repeat exercise 1 and 2. Okay, so let's do another sample. So it wants us to do another one. Let's do another one here. Oh, I gotta change this to 40 again. Do that to 40 and draw a sample. Exactly 20. That's odd. Very odd. I mean, it's not very odd, but it's just weird that it happens right here. So this one would have been 20 out of 20, and we can go ahead and calculate, or 20 out of 40, sorry. We can go ahead and calculate that as 50% easily. Alright, let's do it again just to see what we get. So if we do it again, we get 25 yeses out of 40 flips, and that would equal 63%. So that's a little bit higher than what we had, or it's actually 62 and a half, but I went ahead and rounded up. So that's a little bit higher than what we said in our conjecture, that there could be 60 or up to 60, right? Okay, and you can just keep doing that and see what you would get. So if we did it again, here's only 13 heads. Well, let's see what that is as a proportion. 13 out of 40, that's going to be way lower than 40%. That's about 33%. Okay, so actually we've had, and the reason why we're looking at this, because we said the probability is going to be 50%, just like the principle said. Okay, and this is a fair way of just indicating 50%. Okay, so just kind of getting you some numbers here, looking at, hey, we had 50, we had 45, we had, over here we actually had up to 63%. So we're just taking samples here of the 40 students out of the school, and so we're trying to see what percentage of those 40 students go, and should represent, if they were randomly selected, it should represent the entire proportion. Okay, so let's look at page 3. This says your teacher displays a graph. There it is. This is actually not the one from where I flipped the coins. This is the one from the teacher's edition. So it says describe the shape. If we looked at this shape here and we drew it, it would look something like that. Now, I know we've got one outlier down here, and if we had more down here, we might say that it was skewed left, and knowing that if you're flipping a head or a coin, you know that it should be normally distributed around 50. So we know that this is going to be a mound shape, or it is going to be a, what we would call, normal distribution. Maybe slightly skewed. Okay. Alright, so what was the smallest sample proportion observed? Well, down here we would see that 0.25 is the lowest one. Now, for the largest proportion, we go down here, and it's going to be 0.65, so about 65% of them were heads. So estimate the center of the distribution of the samples. Well, what would you say is about the center? Right around here, right? So us knowing that flipping a fair coin, either heads or tails, you're going to know that the center should be around 50. Okay. Now, does that mean, for what we're looking at in the context of students walking to school and students riding a bus or a car, should that be 50%? Well, no, but our principal made the claim that it was 50%. And so what we did, we said, well, I know that flipping a coin gives me a 50% chance. Okay, the proportion of flipping heads is 50, and the proportion of flipping tails should be 50. So we created an experiment or a test here to see if what his claims would be true, because what we did, we took a sample of 40 students, we asked 16 of them, or we asked 40 of them, and they said that 16 said that they did walk to school. And they said, well, that can't be right, because that's only 40%. Or could the principle still be correct? And so what we're doing is trying to simulate a sample proportion that would be accurate to a 50% probability. Okay, hopefully you're understanding what we're doing here. We're not just flipping coins to be flipping coins. Now it says we'll report the mean and standard deviation of the sample distribution created in the class. Well, we're just going to use the one that is in the sample graph. Okay, so should be very close to 50% or 0.50. That should be the mean, right? Should be very close to the mean. Now, what are we going to look at as far as the random sample of 40 students, and found that the sample proportion of students was walked to school was 40%. Would this have been a surprise result if the actual proportion was 50%? Well, no, because of what we just did. Okay, and if you actually look at the graph, there was some of those samples that was as low as 0.25 and as high as 0.65. So for them to come up with 40 students that had a 40% walk to school rate or proportion, well, that falls within this. Okay, so that should be not surprising. Okay, should not surprise us that we only got 40%. And you know, we did flip it that one time and we got 20 out of 20. So, I mean, 20 out of 40, which was 50%. So, let's see what it says. Answers will vary based on the sample responses, but the value of 40% is about 1 standard deviation from the mean. Okay. There were quite a few samples in the simulation that resulted in sample proportions that were 40 or smaller. Hence, the value of 40% would not be surprising result if the population was 50%. That's what we just said. This falls in between here, so it should not be surprising to us. Okay. So let's go to page 5. This is, what do you think would happen if the sample distribution that you constructed in the previous exercise had everyone in the class taking a random sample size of 80 instead of 40? Justify your answer. This will be investigated in the following exercise. So, why or what do you think it would do for 80? Okay, and you just need to think about that just for a second. If I up my sample size, what's going to happen? Well, if you up it, you're getting closer to the actual population. So the result would be more accurate because there are more samples. Okay. What if I said there was only let's say there's only 100 students in the school, and we just took a sample of 40? That should represent, if we randomly chose them, that should represent the population. But if I said we're going to take a sample of 80, that means we're only leaving out 20 students, right? And so that should be even closer to the actual population proportion, okay? Because you only left out 20 data points. So you're getting closer, you're getting more accurate to the population proportion.